Okay, so let's start with the definition. Piecewise function is a function where different rules are applied for the function in different pieces, okay, of the function's domain. So usually you're going to see it like this. P of x is going to have the first equation or rule, right, followed by the domain restriction. You have a second rule, second equation, followed by domain restriction, and so on. Okay, you can have anywhere from 2 to infinity, I suppose, if you really wanted to. Number of rules. It really doesn't have a limit. So, here's a one with 3, but we can have 4, we can have 5, 10. Okay. Now you guys have actually been getting some experience with piecewise functions and didn't even know it yet because these types of graphs that we've been working on for domain and range have all been piecewise functions. Okay. So if you guys notice, each piece is going to be a different equation, correct? Different equation for this piece. Different equation for this piece, this horizontal piece, different equation for this one, right? And the way it works is, well, this isn't the whole equation, is it? Is this the whole thing? No, it's a piece of that graph. The entire function would continue like this, correct? But this one is just a piece of it. Its domain has been restricted. Okay, we said, no, it's only going to stop here from negative infinity to -3. Yes, this parabola here, it's whatever its equation is, its domain for that particular piece, its domain restriction would go from where to where? From -3 to where? To 1, right? Including -3, but not including 1, right? Same thing for this, right? This one's going from 1 to 3. This one's going from 3 to 10. So we're kind of like taking the original function and cutting it up into different pieces, right? And erasing it. That's kind of the idea. But with this, let's go ahead and see if you guys can evaluate some of these points, okay? So in number 1, let's use this graph to evaluate. So what's P of 0 going to be? So I go to 0, right? I look down at the graph, and it looks like P of 0 is -5. Okay, not too shabby, right? We've done this before. P of 1. So here's 1, and I look up and down at the graph, and what do I notice happening at 1? There are 2 holes there, right? There's an open point. So what does that mean? What is P of 1? It is undefined. Okay, how about P of -3? So at -3, which is right here, we get these 2 values, right? This open circle and this closed one. So which one is the answer? 4. We always take, so at -2, this point is undefined, right? It's not a part of the domain there, but this one is, right? So P of -3 is 4, okay? Will you ever have 2 closed points? Is that something you guys should expect? No? Why not? Here's the hint. These are piecewise functions, right? So why can't I have 2 closed points? Because then it wouldn't be a function. It would fail the vertical line test, right? So that's never going to happen. So you don't have to worry about what happens if that? That's exactly the reason why. If this was a filled in point as well, then you wouldn't know which one to choose from, right? And that's exactly right. We can't do that, okay? We can only have one output for every input. Only one y value for every x value, okay? We can't have 2 y values. So how about P of -6/5? Go ahead and look for that, guys. Take a second. All right. So -6/5, that's about, that's the same as P of -1.2, right? Let's see. We can zoom in quite a bit here, right? So at -6/5, that's about right here, right? What would you guys say that is? So what is the exact value here? So negative what? 4.5. How? Wait, are you sure? 0.3? Negative 4.3? Oh. Ooh. So you guys, okay, I like what you said. Negative 3 point something. Why do you say it like that? Because you can't be sure, right? Here, when you're given just a graph, does it actually make, are you gonna get an actual very exact value here? No, so what we're gonna say for this right now is that we can't get an exact value. But we can approximate, so we can say P of negative 6/5 is approximately what? We can say about negative 3.8, or you could say negative 3.7, right? Negative 3.6, negative 3.9 even, maybe, possibly. But because we are saying what? Are we saying this is equal? No, we're saying this is approximately, right? An estimation. Okay. So now let's try out this down here. Now the reason I put this on here, guys, is because when I put this on a quiz a while back, it destroyed you for whatever reason. So let's take a look at how it actually works. So here, P of negative 3 plus P of negative 1 minus P of 10. Well, this is very simple. We need to first find these values. So what is P of negative 3? So P of negative 3, that was 4. A plus, what's P of negative 1? Negative 4 minus, what's P of 10? 7. So 4 plus negative 4 minus 7 gives us negative 7. So really that's all we're doing, right? That's all you have to do. So let's check out the next one, right? So the next one says 2 times P of 0. So what's P of 0? So 2 times negative 5, right? Minus, what's P of 5? 2, so minus 2. Plus, what's P of 1? P of 1 is undefined. So what happens when you add and subtract things with undefined? It's just undefined. Right? So in this case, we don't even have to do the rest of the calculation because, well, how do you add with undefined? You can't. It's undefined. So this value would also be undefined, okay? All right. So let's continue a little bit. So what should you consider before evaluating a function using only its graph? So for this one, guys, what I'm asking here has to do with P of negative 6/5. What's one thing, if you're only given a graph of a function, what do you have to remember? That what? That you might not be able to find exact values, right? Because for some values, right? For some domain values, you may not be able to find an exact value. What would you need in order to find the exact value? The equations, precisely. So that's where the next part is concerned. So right underneath that, now we have this. Okay, so now we're looking at just a piecewise function written like such. F of x is equal to 3 times x minus 2 plus 1 if x is in between negative 7 and negative 4, not including negative 4. F of x is equal to 8 if negative 4 is less than or equal to x is less than 0. It's equal to, F of x is equal to x squared plus 2 if 3 is less than or equal to x is less than 6. And f of x is equal to negative 2/3 x plus 42 if x is greater than 6. So if I'm going to look for f of negative 6, what do I need to pay attention to? If those of you who need to go, you may go. So what do you have to pay attention to? The domain restrictions. For example, f of negative 6 can I plug it into the first equation? Yes, I can. Why? Because we're saying x is equal to -6, right? And -6 falls in between -7 and -4, doesn't it? So because of that, we can use the first equation. So we can plug in 3 times -6 minus 2 plus 1. What is -6 minus 2? So 3 times -8 plus 1. What's 3 times -8? -24 plus 1 is -23. Now, let's go to the next one. F of -4. So f of -4, can we use the first equation? Why can we not use the first equation? Because it says we can use -7 to -4, but this one does not have an equal sign down here, right? So we cannot use this one for -4. So then, which equation can we use? The second equation. So, what is f of -4 equal to? -8, yes. You see, in this one, it's just a constant, right? So there's no x to plug into, right? It's not -8x. I can't plug in my value. So if there's nothing to plug in, then what do you get out? Just this. So for any number I plug in between -4 up to 0, but not including 0, right? What are any of those values going to be? -8. It's a constant. Okay, it's always going to be -8 in between those. So how about f of 2? Which one can we plug in f of 2? So can we plug into this first one? No, 2 is not in between -7 and -4. Can we plug into the second one? No, it's not in. 2 is not in between -4 and 0. Can we plug into the third one? So 2 is in between 3 and 6. No, it's not, right? Can we plug it into this one? Is 2 greater than 6? Nope. So what happened then? This is undefined, right? And now I think you guys are starting to get a better idea of what undefined means. It's literally there's no equations that are defined, right, for x is equal to 2. Okay, there is if you guys notice, this one stops at 0 and starts again at 3, so there's a gap. Yes? There's a gap in the domain. So, now we have a fraction, right? So, in this case though, okay, let's get approximately what is this? 10 over 3. About 3 point what? 3. Okay, yeah. It's about that, right? So, which equation can we use? Equation 1, 2, or 3? Or 4? We can use equation 3, right? Because 10/3 or 3.3, right, is in between 3 and 6. All right, so let's plug in the exact value. So we will get, so what are we plugging in? 10/3 squared plus 2. So what is 10/3 squared? 100 over 9 plus, we're going to need to make this into common denominators, right? So 2 over 1, what can I multiply 2 over 1 by to give me something over 9? Times 9, right? Times 9 here, times 9 here. So I'll get 18 over 9. So 100 ninths plus 18 ninths gives us 118 ninths. And we'll just leave it like this for now. We might be able to simplify it, but for the time being, we'll just continue, okay? Actually, I don't think you can simplify it. All right, so f of 18, which one would that go into? The last equation, right? So we can say f of 18 is equal to, how do I find it? -2/3 times 18 plus 42. So let's see. -2/3 times 18. So I can multiply negative 2 times 18, and that'll give me negative 36, and that's going to be divided by 3. What's negative 36 divided by 3? Is negative 12, right? So negative 12 plus 42? Not quite. Negative 30, yes? Oh, no, you're right, positive 30. Excuse me, my bad. All right, so what about this last one? F of negative 5 plus f of negative 1 minus f of 4. So we'll have to find f of negative 5. What's f of negative 5 equal to? Which equation can I use this one in? The first equation, so I have to do 3 times negative 5 minus 2 plus 1. So that gives me 3 times negative 7, which is negative 21 plus 1 gives me negative 20. So that's going to be negative 20 plus. So now we have to find f of negative 1. Which one does that fall into? Which domain? Second equation. Negative 1 is in between negative 4 and 0, right? So what is f of negative 1? Negative 8. That was easy, right? Minus f of 4. So what does 4 fall into? The third equation. So I'm going to have to find 4 squared plus 2. 4 squared is 16. So this is 18. So minus 18 in the end. So negative 20 plus negative 8. So I have negative 28 minus 18. What does that give us? Negative 46. Oops. There it is. All right, so that, guys, is how you evaluate with a piecewise function when you have equations. Okay, you're going to get some more practice with that in the homework. So let's now look at the next page, or the other side, I mean. Graphing. Now we have to actually graph these. So there's a couple different ways that you can do this. But I'm going to show you a particular way today. And so what I'm going to do, guys, is let's take this graph. You guys are going to need to have a pencil here, okay? For sure. And I need to figure out how to get this eraser. Just a regular eraser, okay? So let's go ahead and graph this line. Negative 2x minus 7. Just graph it like normal, okay? So it looks like here's negative 7. Oops. Wrong guy there. There's negative 7. And it's a negative slope, so I go up and to the left 2 over 1. Okay, not bad, right? But this graph, where is its domain? Where does it live? From negative 7 to negative 2. So what I'll do is I'll go to negative 7. Go up here. I'll put a closed point, right? Because it does say less than or equal to, correct? And then I will just erase to the left. And it goes until where? Negative 2. So I'm going to erase everything past negative 2. And what do I need to have on that point? That's the open point, right? Now, we can do the exact same thing with the next equation. So, for the next equation, this is in point-slope form. So can you guys tell what point we used here? Well, when you're looking at point-slope form, remember that the inside number here with the x is always going to be the opposite value. So really, this one happens at negative 1. And when you look at this value here, it's plus 2, right? That's just going to stay the same. So that's positive 2. So here's our point, right? And what is the slope? 3 over 2. So I'm going to go ahead and go to this point, negative 1 and 2. And my slope is up 3 to the right 2. Up 3 to the right 2. Or down 3 to the left 2. Down 3 the left 2. Do I really need to do this whole thing, though? Not necessarily. Where do I have to... Where does this one start? At -1. And what kind of point am I going to have there? Solid point. So I can get rid of everything to the left here, right? And where does it stop? At 5. So I'm actually going to have to continue this a little bit, right? Let's see. We can actually just extend it just a little bit. Let's see. Boom, boom. So I go up 3, to the right 2. But it stops at 5, right? Here's 5. Oh, wait, no. A little bit more here. And what kind of point do we have there? An open point. So, you guys just graphed your first piecewise function. Congratulations. Okay? So, number 4 here has a couple of things. So you're going to graph it the same way. Can I ask you guys really quick, before we start putting things away, what is the point that you're using here? What's your points? -8, -6, and what is the slope? 3. Ah, very good. What are you going to do with this constant? This is just 6. What is this going to give you? Do you guys know yet? So that will be this, guys, from -4 to 2, you're going to have a horizontal line. Okay? What's the point that you're using in this one? +2 and 4. Okay? And your slope? -1/3. So,